Alright, so let's continue. I was here. Just Alright. So I have to implement the runtimer method for the stopwatch. The next thing we need to do is create the runtimer method. This method will get a reference to the text view in the layout, format the contents of the seconds variable into hours, okay, minutes and seconds, and then display the results. Okay, and then display the results in the text view. If the running variable is set to true, it will increment the second variable, and then the running we increment seconds. All right, we get the time. String dot format equal default hours minute equal dot get default seconds, and then we increment seconds. Okay, the code for this is below. We will add this stopwatch activity in a few pages. Okay, we've left out a bit of code here to look at it on the next page. Okay, so get the text view, format the second into hours minute, and this is plain Java. So read this code to keep looping so that it increments the seconds variable and updates the text view every second. We need to do this in such a way that we don't block the main Android thread. In non-Android Java programs, you can perform tasks like this using a background thread. In Android, well, that approach won't work. Only the main Android thread can update the user interface, and if any other thread tries to do so, you get a called from wrong thread exception. Okay. So the solution is to use a handler. We'll look at this technique on the next page. Handlers allow you to schedule code. Okay, hold up. Let me just type it and type it for it run. Okay. So I have this function private void runner. Void run timer and does not take anything. Okay, then I need to import the text view. Then we obtain the reference text view. Hold on a second. Alright, so now I'll continue right in the text view, in the reference to the text view, and because the text view is called time view, final text view, so find view by ID dot r dot id dot time view. Wait, then we are leaving some. Get the text view and format the seconds into hours, minutes, and so int hours equals seconds divided by 3600, right? Then int minutes equals seconds, takes the mod first, seconds mod 3600 and divided by 60. And then finally we have seconds, which are actually seconds mod 60. Okay, so we are first keeping them within 3600 and then taking the right. Or it is simply equivalent of 60 or 60, right? But yeah, but I guess you do it this way, this way. Six equals seconds mod 60. Then we have the string time, which we format locale.getDefault. String time string dot format locale dot get default. Okay, it does not have locale. So java.util.locale. Okay, there java.util.locale used for local time formatting. Okay, then we provide in a string with a format. Then we provide in a string with a format. Okay, so 2 slots for minutes, 2 slots for seconds, and hours can be longer. Then we provide in the value hours, minutes, and seconds. Right. Then we finally set the time view with the same text. Time view dot set text is time. Update the time view. Then we have, then if we check if it is running, increment the seconds variable. If it's running, increments the seconds variable. So it's running seconds plus. Other solutions use a handler. Handler allows you to schedule code. A handler is an Android class you can use to schedule code that should run at some point in the future. So you can also use it to post code that needs to run on a different thread other than main Android thread. In our case, we're going to use a handler to schedule the stopwatch code to run every second. Okay. To use handler, you wrap the code you wish to schedule in a runnable object and then use the handler post and post delayed methods to specify when you want the code to run. Let's take a closer look at these methods. The post method. The post method. So the post method posts code that needs to be run as soon as possible. It's usually almost immediately. This method takes one parameter, an object of type runnable. A runnable object in Android will is just like a runnable object in plain old Java. A job you want to run. You put the code you want to run in the runables run method, and the handler will make sure the code is run as soon as possible. Okay. Find a handler. New handler, then new handler dot post. Okay, the post delayed. The post you put the code you want to run in runables. Then we have post delayed. The post delayed method works in a similar way to post method, except that you use it to post code that should be run in the future. Okay, the post delayed method takes two parameters, a runnable and a long. The runnable contains the code you want to run in its run method, and the long specifies the number of milliseconds you wish to delay the code by. Okay, so after 1000 milliseconds, we can simply the code will run as soon as after the delay. Okay, so we have a handler and the handler dot post delayed runnable long. Use this delay for running specified by a number of milliseconds. Okay. On the next page, we'll use these methods to update the stopwatch in every second. Okay, the full runtime. So we create a final handler dot post new runnable, and then we override our. Okay. So within the void run, we are doing this, and then within the post function, handler dot post delete. Okay, so create a new handler. Done. Okay, call the post method passing in a runnable new runnable. The post method processes code without a delay, so the code in the runnable will almost run immediately. Okay. Okay, so this bit of code will run almost immediately. Alright. So we have the runnable run method contains the code you want to run. In our case, the code to update the text view. Right. And the post the code in the runnable to be run again after a delay of 1000 milliseconds. As this line of code is included in the runnable run method, it will keep getting called after a delay of certain milliseconds. So this is it within the post, and within the post we can delay it, right? Alright. So within runnable, we have this handler. Using the post and post delete method in this way means that code will run as soon as possible after the required delay. which in practice almost means immediately. While this means the code will lag slightly over time, it's accurate enough for the purpose of exploring the lifecycle methods. This step. So we want the runtimer method to start running with stopwatch. Okay, wait, hold up. So I'll go update it now. I'll text view. So I first final handler android.os.handler. Used to schedule job alongside the main Android thread. So I will new and then I will define call the handler.post function. Then we'll make a new runnable object. New runnable. Yeah, new runnable object, and within this object, I'm going to override this function public void then function, and within this function we are going to define our code. We define the code we want to run. Define the code we execute. Final. Right. Then we define to run adjacently here. Okay. So then we have this, and within this function we tell the handler to delay executing the function again by 1000 milliseconds. Here we go. Handler dot post delayed. I can pass which function this. Well, 1000 milliseconds. Okay. We have the delay. Okay, so we are just calling this function again, right? Okay, now we want the runtimer method to start running when the stopwatch activity gets created. So we'll call it in the activity on create thread. Okay. So since we want the runtimer method to start executing as soon as the activity gets created, we will call it here. I'll show you the full code for stop activity. So these are the things we need. Then we have second, and we call this function right using these extra classes. So we need to import them. Use the seconds and running variable to record the number of seconds passed and whether the stopwatch is running. Then by using a separate method to update the stopwatch, we're starting it when the activity is created. Okay, to start the stopwatch, this gets called when the start button is activated. Stopwatch sets the number of seconds on the timer. Function sets the number of seconds on the timer. Right. So make sure you update your activity code to reflect these changes. What happens when you run the app? The user decides she wants to run the app on her device. She clicks the app's icon. Then an intent is constructed to start this activity using start activity intent. The Android manifest XML file for the app specifies which activity to launch. Activity user the launch activity. Android checks to see whether there are already process running for the app. If not, create a new process. It then creates a new activity object, in this case, stopwatch activity. Then we have this, on the onCreate method gets called. In the method gets called. The method includes a call to the set content field specifying a layout and then starts running the runtimer method. When onCreate method finishes, the layout gets displayed. Otherwise, the runtimer method uses a second variable to determine what text to display in the text view and uses the running variable to determine whether to increment the number of seconds. As running is initially false, the number of seconds isn't incremented. So you have, why does Android run each app inside a separate process? For security and stability, this approach prevents one app from accessing the data of another. It also means that if one app crashes, it won't take down others will. Why have an onCreate method in our activity? Why not just put the code inside a constructor? Okay, Android needs to set up the environment for the activity after it's constructed. Once the environment is ready, Android calls the onCreate. That's why code to set up the screen goes inside onCreate instead of a constructor. Okay. Couldn't I just write a loop in onCreate to keep updating the timer? No. OnCreate needs to finish before the screen will appear. An endless loop would prevent that from happening. So the runtimer looks really complicated. Do I really need to do all this? It's a little complex, but whenever you need to post code that runs in a loop, that code will look similar to runtime. So we take it for a spin. Right, everything's great. The app. Okay, when we run the app in the emulator, the app works great. You can start, stop, and reset stopwatch. Any problems at all? Without any problems at all, the app works just as you'd expect it. But there's just one problem. When we ran the app on a physical device, the app worked okay until someone rotated the device. The device was rotated, the stopwatch set itself to 0. Let me check for myself. Yeah, it started. Nice. Let's reset. Then start it again. Let's stop it. Then reset it. Great. And okay. Then start it. Then, so it goes to 0 again. Uh, so, there's just one problem. When we ran the app on the physical device, the app worked okay until someone rotated the device. When the device was rotated, the stopwatch set itself back to 0. It was running, but reset to 0 when the device was rotated. So in Android 12, it's surprisingly common for apps to break when you rotate the device. Before we fix the problem, let's take a closer look at what caused it. What just happened? So why did the app break when the user rotated the screen? Let's take a closer look at what really happened. The user starts the app and clicks on the start button to set the stopwatch going. Runtime method starts incrementing the number of seconds displayed in the time view using seconds and running variables. The user rotates the device. Android sees the screen orientation and the screen size has changed. It then destroys the activity, including any variable used by runtimer. Okay, so it destroys the activity. The stopwatch activity is then recreated. The onCreate method runs again and the runtimer method gets called. As the activity has been recreated, the second and running variable are set to their default values. Okay. Okay. So seconds is set to 0 and the running set to pause. This is because the activity was destroyed and recreated when the device was rotated. Right? Okay. The, so rotating the screen changes the device configuration. When Android runs your app and starts an activity, it takes into account the device configuration. By this we mean the configuration of the physical device, such as the screen size, screen orientation, and whether there is a keyboard attached, and also configuration options specified by the user, such as the locale. Android needs to know what the device configuration is when it starts an activity because the configuration can impact the resources that are needed for the application. A different layout might be used if the device screen is landscape rather than portrait. For instance, and a different set of string values might need to be used if the locale is France. The device configuration includes options specified by the user such as the locale and options relating to the physical device such as the orientation and the screen size. A change to any of these options results in the activity being destroyed and recreated. Okay. Android apps can contain multiple resource files. Source files in the app source folder. For instance, if the device locale is set to France, Android will use the strings.xml file in the values-fr folder. Okay, so it all depends on the locale. When the device configuration changes, anything that displays a user interface needs to be updated to match the new configuration. So when the device configuration changes, anything that displays a user interface needs to be updated to match the new configuration. If you rotate your device, Android spots that the screen orientation and the screen size have changed and classes this as a change of the device configuration. It destroys the current activity and then recreates it so the resources appropriate to the new configuration gets picked up. Okay. The states of an activity. When Android creates and destroys an activity, what is the time? When Android creates and destroys an activity, the activity moves from being launched to running to being destroyed. Okay. The main state of an activity is when it's running or active. An activity is running. Okay, the main state of an activity is when it's running or active. An activity is running when it's in the foreground of the screen. It has a focus and the user can interact with it. The activity spends most of its lifetime in the state. An activity starts running after it has been launched, and and the end of its life, the activity is destroyed. The activity object has been created, but it's not running. The activity spends most of the time here. Then at this point, your activity no longer exists. An activity is running when it's in the foreground of the screen. The onCreate gets called when the activity is first created, and it's where you do your normal activity setup. So when an activity moves from being launched to being destroyed, it triggers key activity lifecycles methods, the onCreate and onDestroy methods. Alright. So these are lifecycle methods that your activity inherits and which you can override if necessary. The onCreate method gets called immediately after your activity is launched. This method is where you do all your normal activity setup such as calling setContentView. You should always override this method. If you don't override it, you won't be able to tell Android what the layout of your activity should use. The onDestroy method is the final call you get before the activity is destroyed. There are a number of situations in which an activity get destroyed. For example, it's been told to finish if the activity is being recreated due to change in device configuration, or if Android has decided to destroy the activity in order to save space. Alright, so the onSave instance state method takes one parameter, a bundle. A bundle allows you to gather together different types of data into a single object. So this is the format. Just public void onSave instance state bundle saved instance state. Okay, the onSave instance state method gets called before destroying. On destroy, it gives you a chance to save your activity state before the activity is destroyed. The onCreate method gets passed the bundle as a parameter, right? This means that if you add the values of the running and second variable to the bundle, and then the onCreate method will be able to pick them up when the activity gets recreated. To do this, you use a bundle method to add name value pairs to the bundle. Okay, so bundle dot put. Where bundle is the name of the bundle. It stars the type of value you want to save, and name and value are the name and value of the data. As an example, to add seconds int value into a bundle, you'd use seconds and seconds. Put int. Okay. So you can save multiple name value pairs of data to the bundle. Here's a save instance method in full. We'll add it to the stopwatch activity on the couple of pages ahead. Okay, so we have on save instance state, bundle saved instance state, save instance state dot put int this. Once you have saved variable values to the bundle, you can use them in a onCreate function. Okay. So once you have saved, we can use it in a onCreate function. Put boolean running and run. As we said earlier, the onCreate method takes one parameter, a bundle. If the activity is being created from scratch, this parameter will be null. If, however, the activity is being recreated, then there's been a prior call to onSave instance state. The bundle object used by one save instance state will get passed to the activity. Okay, so you can get values from bundle by using the method in the form get, where star could be anything. Where bundle is the name of the bundle and star the type of value you can get. So in seconds is bundle dot. So putting all this together, here's what onCreate. Here's what onCreate method now looks like. Look at the full code to save and restore. So the updated code, we have this if saved instance equals null. We will come here in onCreate and we'll say bundle lets us pass activity among states when it is recreated. So I'll go if saved instance state is not null, when the activity is created from scratch, this value is null. After that, it will always contain the values specified in on save instance state method equal to second equals saved instance state dot get int seconds, right? This is a key, and then running equals save instance state dot get boolean running. Okay. Right. Then we are overriding on save instance state. Overriding on save instance state to save the current values of the variables. है bundle save instance state. Save instance state, basic, not annotated. Then we'll go with save instance state output dot put int seconds and seconds save instance state dot put boolean put running. Okay. So how does this work in practice? What happens when you're in the app? The user starts the app and then clicks the start button to set the stopwatch going. Then the run timer method starts incrementing the number of seconds displayed in the time view text. Right. Then the user rotates the device. Android views this as a configuration change and gets ready to destroy the activity. Before the activity is destroyed, onSave instance state gets called. The onSave instance state method saves the seconds and running values to a bundle. Okay, I'm going to be destroyed. I must save you. Try to save it within the bundle. The Android destroys the activity and then recreates it. The onCreate method gets called and the bundle gets passed to it. Right. So this activity is destroyed. The bundle contains the values. The bundle contains the values of the seconds and running variable as they were before the activity was destroyed. Code in onCreate method sets the current variable values to the values in the bundle. Then the runtimer method gets called and the timer picks up where it left off. The running stopwatch gets displayed on the device and continues to increment. So make changes and let's run the app. Okay, so we start. Then I rotate the app and start, and then I again rotate the app, stop it. Okay, great. So why does Android want to want to recreate an activity just because I rotated the screen? The on-create method is normally used to set up the screen. If a code in on-create depends upon the same configuration, for example, if you had different layouts for landscape and portrait, then you would want on-create to be called every time the configuration changed. Also, if the user changed their locale, you might want to recreate the UI in local language. Why doesn't Android automatically store every instance variable automatically? Why do I have to write all the code myself? You might not want every instance variable stored. For example, you might have a variable that stores the current screen width. You want that variable to be recalculated the next time on create is called. Is a bundle some sort of Java map? No. No, but it's designed to work like a Java.pt map. A bundle has additional abilities compared to map. Bundles can be sent between processors, for example. That's really useful because it allows the Android OS to stay in touch with the state of an activity. And we have there's more to an activity, so I guess I will continue this next time on.